There's some questions on Chapter 11, so I wanted to be sure that we got those answered. The first question was 11.64. Approximately what amount in REMs of short-term exposure to radiation produces notable effects in humans? So if we look at table 11.6 in the textbook, we see that there's a table that gives this information. So anything less than 25 REM will have no detectable impact on human beings. However, if someone is small, like a child or an infant, we definitely would be really careful about exposure to radiation because they're going to be more susceptible, just as they would be to any poison. Their lower body mass makes it difficult for them to handle any sorts of disruption. The next question is, a typical chest x-ray exposes a patient to an effective dose of 0.02 milli-SV. How many REM is this, and how many chest x-rays would a patient have to receive before biological effects would be observed? And the limit from table 11.6 is greater than 25 REM. So if we look at table 11.5, we see there is a conversion factor between SV and REM, and so we need some conversion factors. We know that a milli-SV is going to be 1 times 10 to the minus 3 SV, and then according to the table 100 REM is equal to 1 SV. So we start out with our given 0.02 milli-SV and multiply by this conversion factor such that the milli-SV cancels out. Put that in the denominator of our conversion factor ratio. Our milli-SV cancels out, as I said, and then we'll multiply by our next conversion factor, 100 REMs per 1 SV, and we arrange that so that our SV cancels out. When we do the math, we get 0.002 REM, and 25 REM divided by 0.002 REM is 12,500. So we'd have to have 12,500 chest x-rays before we would be able to see this notable effect of white blood cell count decreasing. There really is not a whole lot of research done on the impact, and for example, people often bring up that we are exposed to a lot of radiations that is naturally occurring, and that is absolutely true. However, people who work around x-rays all the time, there is definitely an increased susceptibility to cancer. So you do just want to be on the safe side and limit yourself to gamma and x-ray radiation whenever possible, just to be on the safe side.